I'm grateful for the opportunity to talk about what I think is a very important topic, probably now more so than ever, is with the rapid pace of investment and the rate and pace of innovation, what are we doing to actually achieve ROI from those investments in machine learning? And so I'll kind of break the talk into, you can call it 3 different sections. I'd like to tell you what we're going to talk about up front. The first part will be a little bit about the market. What are the signals? What are we seeing? What are some of the opportunities? What are some of the challenges? Then what are some of the capabilities we need to address those challenges? And then I want to introduce the concept of a semantic layer to you all. Maybe you've heard of it, maybe you haven't, but we'll talk a little bit about what's unique about a semantic layer and how it could potentially impact and drive ROI to scale ML and AI investment. Probably something a lot of people have not thought about specifically with a semantic layer. Before I start, are there folks familiar with the concept of a semantic layer? Okay, great. So that being said, why don't we jump right in? No, that is not the slide I want to be on. Here we go. So if we start with the market, I wanted to take an approach that says, before jumping right into ML and AI, how are organizations getting better analysis and understanding of their data? And there's a lot of different ways to show these types of charts. And maybe for the practitioners in the room, the ones that they're most familiar with are these box charts, where you're going left to right or top to bottom. You're showing data ingestion, events, streaming. That data gets landed into another box. Maybe it's a lakehouse, maybe it's a warehouse. It then feeds some analysis, machine learning, AI, there's governance, there's all these different tools. And then at the very, very end, maybe on the right-hand side, or in a vertical-oriented box chart, at the very, very top, there's a little layer, and there's typically some people and some icons. And that is typically representing the consumption layer. I didn't want to show the box chart because you're probably going to hear a lot about the tools and the technologies that are helping fuel the arrows from left to right or top to bottom. I want to start at that consumption layer and maybe work our way back. Because at the end of the day, the talk is about applied AI and the talk is about how do we deliver business impact. So it's going to ultimately come down to how people are organizing their data and where they're making decisions from. So those personas, those tooling choices, those processes matter just as much as all of the arrows that typically are on those complex box charts that are before it and potentially come after it. So I show this chart, and you've probably seen even a flavor of it. It's not meant to imply the most competitive companies are the ones that are going up and to the right. They are, right? But that's not the entire way I would read this chart. So when you look at the different boxes, it's things that we all understand. Reporting, right? Understanding of what happened. Descriptive analysis. What happened, but give me more multidimensional views of it. Diagnostics, how it happened and why it happened. Predictive, what will happen. And then ultimately prescriptive, what's the best course of action I should be taking? Now, it's not about picking one of these and saying, I've got to go do prescriptive, I've got to go do predictive. It's actually looking at large, mature organizations and realizing they've invested in all of these technologies. And it's not one or the other, it's encompassing every aspect of the tools and the processes they've made around these technologies. So in a large enterprise mindset, reporting might be just as important as predictive and prescriptive. And for example, we've all been hearing a little bit about, finance and the importance of a CFO in this current economic climate. Battery Ventures, I think, did a report last year that said somewhere between 73 and 80% of financial analysis is still done in a spreadsheet. So you can go build the most, performant, accurate time series model to go build a forecast. But if that forecast isn't impacting what that financial analyst is doing and building reports for their CFO to then go back to their CEO, you're likely not delivering impact for that organization. So reporting has just as much of an equal say as all of the ML tooling pipeline investments you're making up to the right. And then finally, if you look at the upper right-hand side, which is a direction we want people to be moving in, I think the applied AI opportunity is actually to become huge when we can start to bring predictive plus prescriptive together, not in separate tools. And when you come back to that concept I mentioned about, your favorite charts and, how you like to view the stack, when you think about those personas, the analysts, the business subject matter experts, right? Regardless of the industry you're in, you could either be using popular dashboarding tools, you might have your own custom dashboards. The idea, again, is we want to be delivering smarter decisions, and smarter decisions typically stem from some form of a tool, right? So there's the users. How do I impact users to make better decisions? And then there's the systems and technology. So, I think as Daniel mentioned, I've had some experience in deep learning. So, you think of an example like visual search, right? As an online retailer, I'm doing a whole bunch of complex analyses. I'm doing classification models, feeding detection models, generating embeddings for a recommendation or a feed-forward network. And at the end of the day, that thing is surfacing inside of a visualization on some online retailer's website. So it has to be consumable, right, to that end user. So predictive and prescriptive, I think, can unlock a lot of potential. And you're bringing those two technologies together, but bring it together where, when, and how with the context that decisions are being made. So, taking a slightly different view of the market, let's talk about what's hard, right? And you've probably heard a lot from different speakers on all the great technology, the investments that we're making, and the first bullet here basically is aligned with that, right? IDC is predicting, and you can pick your favorite stat, this year alone, we're gonna have $500 billion in AI solution investment, in AI and ML. And that makes sense, right? When we look at the last 8 to 10 years, the rate and pace in innovation, we started with brute force modeling, we introduced AutoML, we simplified that process. Now we're sort of transitioning more into ML ops and sort of the next phases of ML ops. And what that's indicative of is customers aren't, or large organizations aren't just realizing that machine learning and AI is a nice to have. They're not realizing that it's just about experimentation. They're realizing this is my competitive differentiation. I've made, or I am making, my vendor selection, my tool selection. I'm investing in organizations. Perhaps I'm investing in a chief AI officer. Maybe I have a VP of data science. That's happening, and that has happened. So it shouldn't be surprising that all of that is now coming at the cusp of the rate and pace of the innovation around data science and machine learning we're seeing. But conversely, when you start to look at the impact, and I love the 2 studies that Gartner has done at the end of last year, they basically studied out of the machine learning models that have been trained and in talking to large enterprises, what percentage of them are actually getting deployed? And unfortunately, it's to the tune of 50%, right? So 1 out of every 2 machine learning models may not actually be making it into production, and they're dying on the vine. And then even those that are making their way into production are not staying in production, or they're not able to achieve or impact and create value for the business. So when you take a step back, we understand, okay, it's all about enterprise AI. That's what the focus is. That's what we need to be doing. But at a far simpler level, we're hitting the realization that while spend is up, ROI is low because models are not making their way into production. And there are going to be lots of different reasons why models are not making their way into production. I think I heard the end of the last talk, trust, transparency, it could be skills, it could be resources, it could be available compute, infrastructure requirements. We're going to talk about a slightly different angle on that. I don't disagree with any of those reasons as to why ML models are not making their way into production, but we're going to hit a far simpler approach, which is models need to be used by business decision makers, and we're going to try to understand what that means in the context of this talk. So these are somewhat startling numbers. Maybe people aren't as startled, but the question now is this pervasive? Is this a trend? Should this be a focus for large enterprise and individuals? Another recent study that was done at the end of last year by MIT Tech Review basically interviewed 600 global CIOs, CTOs, and CDOs from around the world. And they asked them very simple questions on what their data management strategy is over the next few years, and what does that mean for business value. And the priorities are pretty clear, right? Over 3/4 of leaders surveyed said that scaling AI and machine learning use cases to create business value is the top priority of their enterprise data strategy for the next 3 years. Top priority, right? So this is now not just about investment and spend. I think the realization that, with the economic environment we're in, with all of the spend that we have in machine learning AI, it's time for return on investment, right? And so that's where the focus we're going to start to see over the next few years. And it also makes sense why, MLOps companies are also on the rise, right? We have our say in how to make MLOps and machine learning models stay in production and achieve value, but we have to do a little bit more. So before we kind of get into the capabilities required, I feel like a professor here just because we're in this room, but I wanted to do a very brief, my brief version of what has happened in AI over the last couple of years and sort of how it's changed, because that's going to help us understand when we come back to the enterprise and we come back to that chart that goes up and to the right, how do I overlay and marry some of the rate and pace of innovation back to the investments that core enterprises are making but have already made, right? That's how you're going to be impactful. It's not just about sandbox environments. It's how do I get into core processes, right? It's not even just about applications. How do I get to where businesses are running? I want the thing that's going to run 1 million times a day, not the thing that runs once and I'm done for another couple of months. So to understand how AI has changed, I'll start with maybe the early days, and the early days I would say are actually still here too. But if you think back 15, 20 years, a lot of this was advanced analytics and statistics, right? Statistical inferences, you were picking your selections, your algorithm, maybe you were using Bayesian methods, maybe you started looking at Hadoop and flat file systems at the advent of big data. Maybe you were starting to work with Spark as an analytic runtime. Chances are you were working on-prem. But it was a very manual, brute force method, and you were spending a lot of time in ETL and cleansing of that data before you apply your statistical models. And then what started to change around, let's call it 2008, 2010, we started to see these AutoML and low-code platforms start to get introduced, right? So it alleviated the burden of all of that manual process, right? I got help with my algorithmic selection. Hyperparameter tuning became simpler, right? And my feature engineering and my feature analysis and extraction and feature impact reports, all of that started to manifest in these tools because they wanted to elevate and upskill data scientists. And the term data scientist started to become more important around this time. And the notion was, well, I just upload a CSV, like upload and go, right? And those AutoML platforms did fairly well, and they're still continuing to do well. And as a result of training, right, the emphasis on the training pipeline around 2008, 2010, that's when we started to see more experimentation and we started to see more model building. And then as those models started to transition to deployment, it became more about the runtime. And that's where we started to see MLOps start to rise more. And around this time, I would say cloud and SaaS became more popular, right? This was 2010, 2012, around that time frame. And then where we are today, and I know these are very big logical leaps, and a lot of things have happened in between, right? We see a lot more around edge, IoT, especially in the advent of deep learning with computer vision, generative AI, we can't escape that hype right now. But just remember, generative AI and some of the networks and models are not necessarily new. T5 have been around for a while, BERT's been around for a while. But what's new is the way you access, build, train, and deploy. Right? So open source has now become much more prevalent. Private APIs are no longer the way that you're interacting with deep learning and perhaps even large language models. And now it's more of how do I take advantage of the compute infrastructure that I have, and how can I also bring model training and even your runtime closer to where that compute lives today. So very similar to what we talked about on that first slide, it's not really an if or, they're probably doing some level of all of this inside of a large mature enterprise. And every enterprise is going to be somewhere different on the spectrum. But for the large enterprises we've talked to, we're actually seeing multiple investments here. AutoML tools, feature stores which have become new, investments in deep learning, private cloud VPC deployments, right? It's all over the spectrum. And that spectrum is indicative of the workloads they're running: batch, online, real-time, structured, unstructured. So again, the reason why I'm bringing this up is the problem for business impact at an enterprise level is far more than what am I doing in my AutoML tool. It has a ripple effect on all of those different processes and tools that I've invested in from the get-go. So coming back to the core thesis of the conversation, it's about business impact. So we kind of have an idea of what's going on in the market, lots of rate and change, a lot of investment. Machine learning and AI is advancing very, very quickly. Open source momentum is moving. But if one of the core things an enterprise is trying to do, is to make better decisions typically require some form of intelligence. And when we think about intelligence, we think about machine learning pipelines, model building, training, and deployment. So conditional, if P then Q logic says, well, if I want better decisions or I'm trying to achieve better decisions, I need some form of intelligence. If I want intelligence, I need some sort of predictive capability that's going to help me aid that decision. Then business decisions really are predicated on predictive intelligence. Now, that seems pretty straightforward, pretty easy to understand, and pretty, something that we should be doing. But the challenge, again, from the beginning has been not building predictive intelligence and creating inferences or predictions. It's how do I make those predictions and inferences available to business decision makers where they're making business decisions, when they're making business decisions, with the context they're making business decisions in. And the TLDR and the spoiler alert is that's not in a Jupyter notebook, that's not in a low-code platform, that's not in an end-to-end AI platform, and it's not in an MLOps dashboard. Coming back to that finance example, it's still in spreadsheets. It's still in common BI tools like Power BI, Tableau, Qlik, MicroStrategy. Right? The users, the business decision makers and users still live in those tools today. And systems and processes, we can have a separate conversation on how predictive should influence the automation of some of those processes. But from the standpoint of making decisions with business decision makers at an enterprise level, that's happening typically in more structured environments. So we need predictive output. So now we're in the capabilities section of the talk. What do I need from a capability standpoint to help address business impact so that I can aid and infuse predictive artifacts, predictive metadata, predictive tables to decision makers? Well, those predictions, first and foremost, should be relevant. Right? So if I'm living in a tool that's not an ML pipeline or a distributed ML pipeline, if I'm in a custom dashboard, my own dashboard, how do I know that as the dynamics of my business are changing, the predictions that are being generated in a distributed ML environment are still relevant to me? Right? Think of like high volatility stock trading. Think of even underwriting. I mean, it's not a great example, but interest rate changes overnight. Right? How do I know that the decision maker or the views that are being generated in my tools and reporting chain, right, that, from all the way from reporting to descriptive, how do I know that what I'm generating in that distributed ML pipeline is still relevant? And then more importantly, even if I'm able to maintain relevance, how do I consume that natively in that tool? I'm an analyst. And a lot of the AutoML platforms will say, we cater to analysts. But let's be real. An analyst is not going into an AutoML platform to make a decision. So how do I publish and automate the publishing of ML metadata active ML metadata back to the business in their tools of choice. And then finally, how do I make it explainable? And it's not explainable in the context of the conversation you guys had before. It's in business terminology, right? So business users are not thinking in terms of area under the curve, F1 score. They're thinking in terms of product, customer, net revenue, profitability. So I want to understand that ML metadata and those ML artifacts in that context, right? Which are more along the lines of dimensions and measures and hierarchies, which is how a business user is framing and using and interacting in their tools of choice. So let's use a very, very simple example to kind of illustrate this point. And by the way, this is based off of some real enterprise customers. So I'm the owner of a brick and mortar retail store. I sell goods, and I ask my logistics and supply chain team, forecast future sales for me. Pretty common. What that team might do? Well, they'll probably have some data scientists. There's going to be maybe some time series modeling. They're going to look at some historical data. But the challenge, before they go and do all of that, I'll call it ML work, there's some dimensions of the data and cardinality of the data that's going to be very important, even for the ML work that they're doing. So the first step would be, well, how are we defining sales? How are we defining revenue? I asked my supply chain and logistics team. They happen to be using, I think this is Power BI Desktop. They're using Power BI Desktop. Great. Their definition of sales and revenue might be very different than finance's definition of sales and revenue, which might also be very different than the sales team's definition of sales and revenue. And what's worse is each one of those teams might also be using different tools. So my sales team might be using a popular CRM tool. My supply chain team is using Power BI Desktop. And let's just pick on Excel or Google Sheets. I know my finance team, regardless of what you give them, there's someone that's still building logic inside of those spreadsheets. So now I have a consistent view of the data problem. What is the actual single version of the truth on those very common attributes? And you might say, well, who cares, Gaurav? I'm building a time series model. Why does that matter? Well, it matters because you're still doing feature engineering. And then let's go back to the fact that maybe you're doing a time series forecast. That implies you're working with time in a time relative measure. How are you defining time as a data scientist? Maybe your finance counterparts are not using a fiscal calendar. Maybe they're using a 554 calendar. Maybe the business week starts on a Sunday, not on a Monday. Right? So anyone who's actually built and deployed ML models and are keeping them in production know that even these small nuances, while they seem pretty little, can have a massive ripple effect on the retraining that you're going to have to do with your data sets once you've deployed and realized there's something wrong. And this is going to be costly and time consuming. So what do we do? Well, this is the third part of the talk. Let's introduce the concept of a semantic layer, and I'll tell you how this can start to bridge to what I just described. So if you've not heard of a semantic layer, it sounds like some people have. I did 2 searches, the second one mainly because of the context of this venue. But the first one was I did a Google search, and Wikipedia came back with a result. A semantic layer is a business representation of corporate data that helps end users access data autonomously using common business terms. And I accentuated and bolded some of these components because I actually think this is a very good and accurate definition. So if we take a step back, business representation of corporate data. To me, that means business friendly. I shouldn't have to require a SQL expert to help me understand my own data. Access data autonomously. That seems a lot like self-service. I shouldn't have to need IT or a data architect to work with my data. And then using common business terms, that to me is business relativity, right? So they're not thinking in row or column equals 10. Most of these business users are thinking in customer, product, sales, churn, different types of semantics. And then for context, I also asked ChatGPT, give me the definition of a semantic layer. Sure enough, it gave a pretty accurate definition. I'll let you guys read it, but we'll talk more on this next slide on some of the things that even ChatGPT brought up. Now that you have a little bit of an understanding of what a semantic layer is, where does it fit in the stack? And the first thing I'll tell you is the concept of a semantic layer is not actually new. Semantic layers have existed since the early 90s when business objects started talking about business universe. And historically, they've been tied to BI tools or data platforms, right? So if you look at Tableau or Looker or even Power BI, these tools have their own versions of a semantic layer that work natively and are coupled to those platforms. And then conversely, if you're looking at a data platform, maybe you're using, the medallion architecture, and you're going from bronze to silver to gold, where gold now becomes the tables that are part of your consumption view. A lot of folks in that sort of mindset define those tables as a semantic layer. Now, the challenge with using either one of these types of semantic layers is in the case of the BI tool, even if you start with a view of a semantic layer that's coupled to a BI tool, you still have to understand the physical data that it's being connected to. And that's going to require complex SQL and probably data modelers. And then inversely, if you start with the data platform, you're going to often work in a very rigid environment. And then it's that last mile of analytics that's now required to get that published to the consumption layer that you're going to have to manually be dealing with. So with all of that, we introduced the concept of an independent universal semantic layer. And the idea here with a universal semantic layer is it does 4 key distinctive things. 1, it helps you create a common definition of business logic. Your dimensions, your measures, the things, the actuals that your business is measuring their KPIs off of. 2, it makes it easier to augment, to add, to create. Businesses are dynamic, things change. You should be able to effectively modify and augment those business metrics. So we need a simple way to do that. 3rd, you can connect to all of the tools you want. You can be as universal as you want. But if you don't have performance, no one's going to use you, right? So a universal semantic layer not only has the understanding and wherewithal to understand different dialects of different tools that are connecting to it, it also understands the dialect of the SQL of the underlying warehouse that it's running on. And the power of that is any query that's coming in automatically gets pushed down for price, performance, compute efficiency to that underlying warehouse, meaning we are not extracting data. Data stays in your backend system. And we'll talk about why that's also important for AI in a second. And then finally, the 4th point is even if I can get consistent views of the data, even if I can create, augment, and change metrics as my business needs to, and as I start to get price performance, I still have to have governance and control. Right? So that's a big theme of this, conference. So how you do authentication, protocols, all of that has to work with a semantic layer as well. Maybe you're publishing to a catalog, right? A universal semantic layer should have APIs that are extensible so that you can publish things like XML and create views in your catalog so that as you're doing downstream policies, policy management, you have that single version of the truth that's being published to other downstream systems. So how do we sort of take this to the next level, and how does this now start to influence what we're doing with machine learning and AI? The concept of a universal semantic layer is what we're focusing on at AtScale, and you can think of it as a logical layer that sits between your consumption tools and your backend systems. And now we have a single place to define business logic within the enterprise, regardless of the tools, regardless of the backends. And it gives us a distinct advantage because there's 2 types of metadata that we're going to start to be interacting with. And we call it passive and active metadata. And the reason why I like to show this slide is as we're transitioning more to cloud, you start to hear clouds are becoming, the center of data, right? Data gravity is going to the cloud. We have a very similar analogy that says, well, knowledge knowledge gravity should shift to a semantic layer, right? We need that universal point and consistency. So what we start to build is views into managing and manipulating passive metadata, right? Cardinality of my data, where it's stored, how it's structured, where is the data coming from, what's the granularity and the size of the data that I'm working with. Pretty typical metadata that you would have seen in maybe any one of these talks. Where we extend it to is now what we're calling active metadata. So active metadata is I'm in my BI tool, I'm making changes, I'm publishing new artifacts, I'm building new measures for the business. Where do I reflect that? And how do I ensure that when I build something new that gets propagated to all of the other downstream tools that are now connected and require it? And then more importantly, a universal semantic layer shouldn't just be focusing on BI-specific dialects. A universal semantic layer should also be able to talk to distributed ML and AI pipelines. So this is where the concept of AI-specific libraries start to come in. Python, as an example, can be another dialect that now a universal semantic layer can employ as a first-class citizen within its ecosystem. And what that allows you to do is connect into any Python-based environment that's being used. That could be for data engineering purposes, that could be for data science purposes. I'll talk about those capabilities in a second. But to me, this becomes the important aha moment of business impact is still going to come from business logic. That business logic needs predictive capabilities and predictive artifacts, but those artifacts are only going to be impactful as the business logic that they're assigned to, right? So now let's get more into detail on the next level deeper on what are we doing with a universal semantic layer to scale machine learning and AI based on everything we just talked about. So if you think again of a universal semantic layer as that business metrics layer, right? This is where your logic is being defined. There's two different ways and two different types of personas that we see could use and benefit from that logic. So the first are, I'll call them developers. Data scientists, data engineers. And we have a term called managed features. The concept of that is once you've defined the business logic inside of your universal semantic layer, that should be an input to your developer. If you're a data engineer, you're probably managing complex data pipelines and you want a more programmatic way to interface and interact with your data and your business logic. This becomes a way to do that that's tied to all of the other tools that you're already working with. So you're never working on outdated data, and you're always using the most refreshed view that's controlled and governed. But for this room, the other developer that we often talk to are data scientists. So especially when it comes to things like structured, tabular, data-centric AI, you're working off of data, and you're extracting data into some tool, some data frame, in some distributed pipeline. Why move the data? Why not leave the data inside of your data warehouse, one of your most price-performant, powerful systems that were designed to do data manipulation, and use that now as an input? So there are different ways a data scientist can interact with our managed features capability. You can directly access and pull business-defined features or business-defined logic directly through Python, or maybe you're using a feature store. So our universal semantic layer would effectively be publishing business logic to a feature store, which would then be the point that a data scientist comes in and starts to read and write from that feature store. But the idea is we are scaling developers within their training pipelines by giving them access to business-relevant actuals. They shouldn't have to be redefining logic. They shouldn't have to extract more data than is necessary, right? And they shouldn't have to duplicate logic. So in that forecasting example, they'll know exactly what key measures, they'll know exactly what the key dimensions are, and they'll know exactly the hierarchies that they should be working off of as they start to build their time series model. And then more importantly, we know that that's not going to be enough, right? The business features or the logic that's defined inside of a semantic layer is just an input. Now they can augment that with any of their other feature analysis, right? For their hyperparameter tuning, for their various SLAs that they're going to start to control. So that's sort of capability one. Capability 2 is more focused on the runtime. And it's about how do we publish ML metadata that lives in a distributed ML pipeline back into a universal semantic layer. And why would we do that? Because mostly what's connected to a universal semantic layer are business-friendly tools. So now, if I can incorporate that metadata back into the semantic layer, my business analyst who knows nothing about an ML pipeline, nothing about ML model metrics, can very quickly, ad hoc, hit refresh in their dashboard and quickly augment historicals with now live predictive data. So the first capability we introduce here, we call it semantic predictions. The concept is in your distributed runtime environment, you have some model serving capability. We don't care what that is. Provided you can talk to a Python-based environment, you point us to those live prediction tables. We'll take those predictions and we'll write them back into our semantic layer. When we automate that we call it a write back. When we automate that write back, we give you the flexibility to join that to anything that's already been defined inside of our semantic layer. So perhaps there's a dimension, store dimension. Maybe there's a customer dimension or a customer measure that you're interested in. You're not just writing back prediction sets. You're writing back predictions that now live as a first-class citizen inside of a table-oriented infrastructure that can now be queried and sliced and diced immediately. And I'll show you an example of what this looks like on the next slide. But the concept here is how do we bring that predictive insight that doesn't live in a BI tool or in a dashboarding tool into a BI dashboarding tool without replicating or creating complexity, right? Everything is still staying controlled in the same environment. And then finally, the last capability we have is called on-demand inference. So imagine now you're an analyst sitting inside of a dashboard and you just got the request from me. I want to forecast future sales. In the prior example, I said we were going to point to a distributed runtime and you were going to write the predictions back to us. Here, we take an ML model that's been trained by some distributed data science team and we register that inside of our semantic layer. And so what we're doing is when an analyst comes into their tool and they start to interact with measures and the things that they're commonly using day to day, in addition to getting some feedback right from that measure, they're also triggering the deployment and runtime of that ML model by using AtScale or our semantic layer and the underlying database and warehouse. So what the user experiences a prediction table or a prediction set coming back live. What's actually happening under the covers is they're running an ML model using a universal semantic layer. So how that sort of manifests back into my example, this is a real example, I wrote back predictions from my distributed ML environment. It was a time series model, and it's a little hard to read, but what they were able to do was very quickly pull that predictive table and the predictions alongside their actuals. They created a very simple error calculation, and they said, show me actuals versus predicted over the last 30 days, over the last 60 days, over the last 90 days, right from within Power BI desktop. And the beauty here is when data changes, when your inputs change, all you're doing is hitting refresh, because the universal semantic layer, because it's connected to those complex data pipelines, knows that the data has changed. And so we have ways on how we do things like model versioning with your distributed ML environment so that we always know that your ML models and the versions of those ML models that you're running are consistent with the latest data that the business is using. And there's feature store integrations that we're working with there as well. But the idea here is now I'm empowering that analyst who lives in this dashboard to start making more predictive plus prescriptive decisions natively within their tool without ever stepping foot into a distributed ML environment. And the question we often get asked is, well, some of these tools start to do that. They have built-in forecast. And I'd say, sure. Are you going to trust a BI tool's ability to generate a ML forecast? Or would you rather take advantage of the ML investment that you've already made inside your enterprise? You've built a COE. You've built a distributed data science team. You have data scientists in your line of business. You have a VP of data science. Let them do the work. Let's productionalize those models faster by getting the predictions in the hands of business users to almost A/B test. right? And get these models into production. So I'm kind of at the end here, but I wanted to add a little bit of generative AI context since I know we're here and it's an area I'm very excited about. But when we come back and take a step back, we talked a lot about processes and applications and different types of workloads. I think for generative AI to have enterprise impact, they're gonna have to have the context of the things we were just talking about, right? Office 365 and GitHub Copilot and Bing are great first examples of applications that can start to leverage large language models. But when you talk to large distribution or manufacturing companies, how am I going to do ticket handling, ticket routing, underwriting, expense management, right? Some of the core day-to-day processes that are effectively running the business. How does generative AI start to influence and impact that environment? And then as we think about how that's going to be possible, the context of a lot of this talk has been around context, right? So AI and the ability to impact your business is only going to be as good as the context you have of the business. So if we want generative AI to start taking off, right, we need to, one, move outside of a private endpoint, which we're starting to see. And I think we're going to start to see more contributions in the open source. But context is still required in different spots between your complex data pipelines and your ML pipelines. So for example, when we're labeling data, right, there's big discussions on if I'm using synthetic data, what does that mean for an organization that has their own private data sets in-house, right? Is there context awareness that they need? Governance, I think, is going to change as a result of generative AI. Right? How do I gain visibility, auditability, traceability within my end-to-end data and ML pipelines when I have these new language models being introduced? And then sort of everybody's favorite topic on ethics. I think this is going to be a pretty hot topic probably for the next couple of years on bias. And again, having more business context around these large language models as they're getting trained, as compute as intensive as they are, is going to help go a long way to make sure that these models aren't biased and are not introducing bias when they're deployed. And then finally, when we think back to that very first slide, up and to the right was prescriptive and predictive. How do we bring large language models and generative AI more in the augmented intelligence space? And I see sort of Office 365 as the first interesting step there, targeting sort of business users and very business-friendly tools. But what are the next set of tools that we need to start augmenting to make that possible? So I think I might be at time. I hope you found this useful. And my goal is, at the end of this, you at least have a better understanding of what's happening in machine learning and AI, maybe some of the pitfalls that are preventing people who have invested highly in it from getting return. And maybe you'll start to look at a semantic layer to say, hey, this is something that can help me both on my BI metric store and my ability to control metadata more generically in my enterprise. And it has added value and benefit for scaling my machine learning initiatives. Thank you.